Good morning, this is Mrs. Perry, Wakefield Wildcats. Hi everybody, hi TUSD. I hope everyone is staying home and staying healthy. I miss you all and I can't wait till we're all back together. Today I am here to do another math lesson. I hope you caught my fractions lesson last time. Today we're going to be talking about division. So just a little quick refresher and reminder, division means splitting into equal groups, equal parts or groups. So we're taking an entire amount and we're splitting it equally into groups. There are two ways that you will see division problems written. 1,346 divided by 4 or 1,346 divided by 4. Either way, same problem, same solution, just written in two different formats. I also want to take a minute to talk about the parts of a division problem. It's really important in math that we know the vocabulary, that we have those math terms, that they make sense to us. Because we won't always see a problem like this. Sometimes it's going to be a word problem, and we need to understand what those words are asking us to do, what math function they want us to perform. The whole amount that we start with, that's called the dividend. Here we have the dividend. That's the entire amount that's going to be separated. The amount that we're splitting it, the number of groups that we're splitting it into, is called the divisor. This number 4 is the divisor. That's the number of groups that we're splitting this whole amount into. The answer that we get is called the quotient. That's the answer to a division problem, the quotient. And if we have an amount left over that doesn't fit into the equal groups, that's called the remainder. Your remainder, that's the amount that doesn't fit into equal groups. So one more time, we have the dividend, the divisor, the quotient is our answer, and any amount we have left over is called the remainder. As I mentioned just a few minutes ago, there are words, key words, if we're reading a word problem, that indicate to us that we need to be performing the division operation. So we might see something that says, what is the quotient of one number and another number? The quotient is the answer that you get when you divide. So it's asking you to divide those two numbers. It might just simply say divided by. Or, as in the definition, it might say split. Split this number into equal groups. Both of those are good indicators that you need to do division. And finally, you might see the word per. If you have a word problem that says, how many per bus? How many students will there be per bus? That means you're going to divide. You're going to split them into equal groups. So remember, if you're looking at a word problem and any of these phrases appear, that's a really good indication that you need to divide. So today, with this problem that I showed you, 1,346 divided by 4, we're going to solve this in two different ways. Because, as we know, there's always more than one way to solve a math problem. And all of us learn a little bit differently. So we have to find that solution that works best for us, the one that makes the most sense, the one that makes us go, aha, I know how to do this. So the first way I'm going to solve this is by using a number bond. And then the second way we're going to find the solution is with a standard algorithm. So grab your paper and pencil and work along with me. So we have our dividend, 1,346 divided by our divisor of 4. 1,346 divided by 4. The first way we're going to solve this is using a number bond. We're going to break this dividend up into smaller pieces that make it easier for us to solve. And the way that we decide how we're going to break that dividend up is by using multiples of 4. So our first step is to write our multiples of 4. Let's say those together. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. I wrote the multiples of 4 from 1 through 10. I'm going to label those because that is going to help me come up with my quotient. 1, 2, 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7, 4 times 8, 4 times 9, and 4 times 10. We have our multiples of 4. So we're going to use a number bond to decompose our dividend. The first place I'm going to begin is in my thousands. I have 1,346. In the thousands place, that means we have 3 zeros. 3 groups of 10. 1, 2, 3. So I'm going to use my multiples to decide which one of these, if I turned them into thousands, would come closest to 1,000 without going over. Well, my smallest number is a 4, 4,000. That's already way too big. So I know in my thousands place, I can't use any of the multiples. So I'm going to move over to my hundreds place. In the hundreds place, we had 2 multiples of 10, 2 factors of 10, 2 zeros. 100 has 2 zeros. So for my multiples, I'm going to turn these into hundreds. And I want to see which one can I use to get the closest to 1,346. 400, 800, 1,200, or 1,600. Well, that's too big. So the one that's going to be the closest multiple is my 12. My 12 is closest to 13 with 2 factors of 10 for hundreds. So I started out with 1,346 and I've now decomposed that by taking away 1,200. So I still need to decompose 146. I'm going to be working in the tens place. Tens, 1 factor of 10. The number 10 has 1 zero. So each multiple can have 1 zero to find a number closest to 146. 1 0, 40, 80, 120, 160. Well, 160 is too big. So my closest factor to this 14 is the multiple of 12. And it's the factors of 10, so 1 0. So now I decompose that, and I have 26 remaining. I'm going to work in the ones place. Our ones place has 0 factors of 10. There's no zeros at the end. So I'm trying to find my multiple that is closest to 26. So I'm going to look at my list, 4, 8, 12, 16, 20, 24, 28. 28 is too big, so my closest multiple is 24. Now you'll notice I've already used all the digits in my dividend and I have 2 left. So I'm just going to put that right here as a reminder that I still have 2 remaining. So I still have the same division problem. I still have 1,346 right here. I just decomposed it to make it easier to divide. Easier to use mental math, easier to use my multiples over here. So now each one of these has to be divided by our divisor. Divided by 4. Divided by 4. That's where my table comes in. So I have the multiple of 12 divided by 4. 12 divided by 4 is 3. 12 divided by 4 is 3. And I have those 2 factors of 10. I have to bring those with me. Again, I have that same multiple, 12. 12 divided by 4 is 3. And I have that 1 factor of 10. I have 24 divided by 4. 24 divided by 4 is 6. Right here, I have partial quotients. Partial. Let's look at that word, partial. The beginning of that is part. That means these are each part of my quotient, part of my answer. So now I take these partial quotients and I add them together. 300 plus 30 plus 6. 0, 0, 6, 0 plus 3, and 3. My quotient, these partial quotients gave me 336. But I can't forget, I had 2 that did not fit into any of these categories. I had 2 left over. This 2 is my remainder. I have a remainder of 2. What that means, if I take this amount, this 1,346, and I split it into 4 equal groups, each group will have 336 pieces. Each of those 4 groups will get 336 of this amount. But I have 2 left over that don't go into the equal groups because that would make 2 groups have a different amount. So my remainder is 2. My quotient is 336 with a remainder of 2. So that is solving this division problem by decomposing the dividend into a number bond. All right, let's look at this in another way. Let's look at this just using the standard algorithm. So we have that same equation, 1,346 divided by 4. I'm still going to take advantage of having my multiples written down because they will help me in solving this. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And I'm going to label them. 1 times 4, 2 times 4, 3 times 4, 4 times 4, 5 times 4, 6 times 4, 7 times 4, 8 times 4, 9 times 4, 10 times 4. Here's my multiple, and here's what's going to be used as my quotient. So I look, how many times can 4 go into 1? Well, my smallest multiple up here is 4, so this is going to be a 0. 4 goes into 1 0 times. 4 times 0 is 0. We subtract. We bring down the next number in our dividend, and we now have 13. And we do that process all over again. How many times can 4 go into 13? 13 divided by 4. So I want to look here. 4, 8, 12, 16. The closest multiple to 13 is my 12. 4 can go into 12 3 times. So directly above my 3 in my quotient, I'm going to write a number 3. 3 times 4, 3 times 4 gives me a multiple of 12. Subtract those, and now we work with the next digit in our dividend. And we start that process all over again. 14 divided by 4. 14 divided by 4. 16's too big, so we're back at that 12. 4 can go into 14 times, 14 3 times. So that goes in our quotient. 3 times 4 is 12. We subtract 4 minus 2, and we bring down that next digit in our dividend. And we start the process all over. 26 divided by 4. We look at our multiples. I want to find a multiple closest to 26 without being too big. 4, 8, 12, 16, 20, 24, 28. 28 is too big. That's larger than 26. So our closest multiple is 24. That means 4 can go into 26 6 times. This is our quotient. This goes up in our quotient. 6 times 4, 6 times 4 is 24. 6 minus 4 is 2. We have completed all of the digits in our dividend. So that means this 2 is what is left over. This is our remainder of 2. So let's look at these. Whether I solve this using a number bond to decompose, or whether I solve this with standard algorithm, my quotient is 336, remainder 2. Keep working on those math problems out there, kids. Keep working that brain, growing that brain every day, and practicing. I miss you all. Take care. Bye.